Hey, Ethan here, and I'm back with my friend Tio.
Hi, I'm Tio, and I'm in my third year of electrical engineering, and I have 3 years of robotics experience.
So in this video, we're going to be talking about design thinking and going through the brainstorming process of everything you need to know about getting from the contest description to a very good idea of what you're going to build.
So the first step is to identify what the problem is and what you're trying to solve. So you want to read through the project description and understand the problem that is being presented.
So once you've read through it a couple times, maybe 2 or 3, you'll try and understand what actions need to be done. So for instance, if the contest is about moving foam golf balls to the other side of the field, one action would be picking up those golf balls and another would be getting them to the other side of the field. And how would you go about doing that?
So you want to research the different ways that these actions can be done in the real world. So how are golf balls actually being picked up on golf courses? And you can do this through YouTube or sources like the internet.
Once you have a good idea of the physical things your robot needs to do, you're gonna have to brainstorm ways to achieve this. So I like to ask a lot of questions and get other people's input on how they do this.
So for example, you might ask, how is your robot going to move? Or about how it's going to pick up stuff.
Another question you'll want to ask is where you're actually competing, what physical aspects of that environment are going to impact your robot's performance. For instance, everyone there is going to be competing with transmitters or Bluetooth controllers like the PS4 controller. How does all of those signals interfere with yours? And you might want to take that into account. Or other aspects like humidity. If you are trying to stick something to an object, how does humidity impact the stickiness of that surface? Ideas like this are kind of the thing you're going to want to think about, just so you have a good idea of what to expect when you get there and kind of compensate for those physical changes in the environment.
So a question you might want to ask is, what is the practical function of your design? So how is your robot going to move? How is it going to manipulate things? These may be obvious, but never overcomplicate things. Simple is always better.
One brainstorming technique I like to use is sitting down with a group of people and kind of presenting them the problem and getting everyone's input on the solution. They don't know the scope of the project and they don't know the constraints of everything. So they'll have very broad ideas which you'll need to use and maybe eliminate the good ones from the great ones and try and find the best ideas out of the group and implement those into your robot. Ideally, at the end, you should have 3 different ideas on how to complete one problem and then write a pros and cons list maybe of each of them and choose based on that.
So at this stage, I like to sketch and make detailed notes about the solution.
So for example, if we're trying to sketch ideas of how to move our robot, there's many different ways you can do that. So if your robot is a square here, you can have your 4 wheels like this. The 2 back ones could move, and then you could use 2 omnidirectional wheels to allow for rotation around the center axis here so that your wheels don't rub against the floor and they can rotate smoothly. Another idea for moving would be maybe you want your 1 wheel in the front and 2 wheels in the back. 2 wheels in the back are driving wheels and the one in the front is an omnidirectional wheel. So again, it allows for pivoting with this front wheel rotating smoothly side to side. Another interesting solution would be if you want to have your wheels on the corner like this. That way you can move in all directions. You can translate left and right, forward and backwards, and rotate around the center of your robot. That's an interesting movement solution. So just ideas like this on how to brainstorm and sketching different solutions can really help with pinpointing the right option and which solution goes best with the course description, really. Because sometimes you need to move around really accurately. So if you have something you need to line up with, so say if I want to line up with this bar, coming in with this robot would be very beneficial because you can translate this way and then move up. And then if you're off a little bit, you can just move to the side and move to the side. Whereas these ones, you have to get it right on the first time when you're kind of swooping in here, because you can't move sideways. You'd have to realign and come back and it gets annoying. So depending on what your contest description shows, you can choose different movement solutions. These are just a few, but there are many out there. Looking at software options for further development of your robot, because the kit doesn't have everything that you'll need. There's not really parts already developed for your specific solution. So you may want to look into alternatives like 3D printing or laser cutting parts out to add on to your StudiKit kit, or building your StudiKit kit out with different components.
So the software that I recommend is SolidWorks or Fusion 360. You can take your 3D parts and put them to life on a computer. Then you can 3D print these parts and add them to your robot.
So the Tetrix website has most of these parts 3D modeled already. So even designing your robot in 3D space is a good idea, because it allows you to see your fitment and adjust accordingly and see how the parts that you've developed can fit into this. So for instance, for my robot, my whole robot was 3D modeled using that included Tetrix 3D drawings, and then I was able to model around that and add on different parts. Thank you so much, Tio, for helping me describe brainstorming to this wonderful audience. Catch us in our next video, where we're going to be diving deep into the building process of these robots and showing you how to bring your robot from your head into your hands.